Morning class, this is Sir Alex. Welcome back to Physics 2. And today, yung topic po natin is about electrical resistance. It's still a continuation from the previous lessons. I think it was 12 and 13, electric current. So before we discuss what electric resistance is, okay. Okay, good morning class, this is Sir Alex. Welcome back to Physics 2. And yung topic po natin today is Lesson 14, electrical resistance. So before we start talking about electrical resistance, let's talk about something very important first. This is what we call a Ohm's law. So Ohm's law talks about the relationship between three things. It talks about the relationship between voltage, current, and resistance. So later I will explain what is resistance, but first let's talk about these things. We've discussed about voltage. We know that voltage is basically the electric potential. It's the difference between electric potential. It's a potential energy per unit charge, and we use the unit volts. We usually get our voltage from a voltage source, similarly like a battery when we hook up a capacitor. Next is current. Current is basically the amount of charge that travels per unit time. So it is the movement of electron per unit time, and we use the unit ampere or coulombs per second to denote current. So now let's talk about resistance. So resistance is basically how much charge flow is impeded. So when we have a circuit, a wire, and a current or electrons are traveling through that wire, uh, because of the material of a wire, sometimes the current that is flowing through a wire gets impeded. When we say impeded, parang hindi smooth yung travel niya. Kumbaga, there's a friction that prevents it from traveling very, very fast or traveling smoothly. So yung resistance is basically uh, uh, comes from the makeup material of the wire or the capacitor or a conductor that prevents the travel of the electron smoothly. And we usually use the unit ohm, which is the symbol right here, to denote resistance. And the device that we use to add resistance to a capacitor, not a capacitor, to a circuit is called a resistor. So by Ohm's law, we know that the relationship between these three is that the voltage is equals to the current multiplied by resistance. Simply rearranging the equation, we get that the current is equals to voltage divided by the resistance, or that resistance is equals to voltage divided by the current. So to help us explain further the relationship between the three, let's think about an analogy of a cylinder or a pipe cylinder. And inside this pipe cylinders, there's water traveling down the pipe, and this water is being pumped by a device, by a pumper. So how do we denote these three in this type of analogy? Yeah. So our pump is basically our voltage. It is the one that uh, gives energy for the water to flow through a pipe. So similarly, the voltage is the one that helps for the electron, is the one giving an electric field so that the electron can move. We've discussed that in lesson 13 and how electrons move, which is the drift velocity. So when we add electric field due to a battery or to a voltage source, the electrons move. Similarly, if we pump a water through a pipe, cylinder pipe, the water moves. So this is our voltage. So similarly, a pump is our voltage. So a current is basically the amount of charge per unit time. So this is the number of charge or the total charge traveling at a point per unit time, which usually when we say time per second. So for example, we have this ring right here, this cross-sectional area, how much charge or basically how much water is traveling per unit time at this point in our pipe. So this is our current. So this is the charge per unit time. So what is resistance in this analogy? So resistance is basically the one that prevents the water from freely traveling a pipe. So this could happen if we actually bottled up a pipe. So if we lessen the area, so if we make it narrower, it makes harder for the water to travel. So the number of charge here actually lessens. So bumababa yung amount of water that travels through a pipe kasi mas maliit yung butas na kailangan niyang pasukan. So similarly, yung current mo mas mababa, and usually your current at this point and your current at this point and these points are all equal, and it usually follows the how small yung area or cross-sectional area na pinapasukan ng tubig. Kasi kahit na mas maraming tubig dito, since konti lang yung pumapasok, yung time ng pagpasok ng tubig dito is parehas lang basically ng time ng pagpasok ng tubig dito. Similarly, yung time ng pagpasok ng tubig dito is kasimbilis lang ng time ng pagpasok ng water dito. So if we think of the water as the charge, so the time for the charge to pass through at this point is same as the charge that passes through at this point and at this point. So all the current at any of this point, when you have a resistance, so when you bottle up a neck, are all basically yung I niya is similar. So ito yung tinatawag natin resistance. So things that prevents the charge to travel smoothly, or it impedes the charge flow. So if we look at a clear example of a circuit, so we have a voltage source, usually it's a battery, and we've discussed before that because of the electric field that is caused due to the potential difference, or the electric potential or the voltage coming from our battery, our electrons travel, right? And we usually denote the current as a movement of those electrons. As you can see dito, usually the electrons are the one traveling, tama? So they're traveling along our wire. So ito yung wire natin. So electrons travel along our wire. So if we remove this switch, there's no connection between the voltage, there's no electric potential, therefore there's no voltage, therefore there's no current kasi hindi connected yung ating circuit. And we denote resistance with a zigzag line along the wire. So when you see this symbol in a circuit, it is usually denoted as a resistance, and the device we use in this system is usually a resistor. So kung wala ito, yung travel ng electric current natin is smooth, and if we added the resistance, bumabagal yung travel ng electric current. And similarly dito, kahit nandito lang yung ating resistance, yung bilis ng pag-travel ng current dito at yung bilis ng pag-travel ng current dito or dito are all the same. It's because they're all impeded by the resistance. So ganun yung Ohm's law. So this is an equation that I want you guys to be very familiar about. The voltage is equals to the current multiplied by the resistance. And using simple algebra, you can derive the equation for the current and resistance, which is basically current is equals to the voltage divided by the resistance, or resistance is equals to the voltage divided by the current. So example, problem 14.1. The filament in a light bulb is a resistor. So meron kang light bulb and yung filament is a form of resistor. And it's a form of thin piece of wire. And the wire becomes hot enough to emit light because of the current in it. If the flashlight uses two 1.5 volts batteries, effectively a single 3 voltage battery, 3 volts battery, To provide a current of 0.40 ampere in the filament, what is the resistance of the glowing filament? So, ang tanong niya is, ano yung resistance ng filament na to if we want a 3.0 volts battery to provide a 0.4 ampere of current. So, let's try and solve this. So, first, let's write our given. So, our given first is voltage, which is 3.0 volts, and we are given the current, which is 0.40 ampere. To solve for the current, we're just basically going to use the equation or the formula that we've learned earlier. So a current, or usually the voltage, is equals to I multiplied by R. Rearranging it, we get that the resistance is basically the voltage divided by I. And we can just plug in the number and solve for the resistance. So voltage of 3.4 or 3.0 volts divided by 0.40 ampere is equals to 7.5 ohms. So that's how easy to use this equation. It's a very easy relationship, and this is what we call the Ohm's law. Okay, so furthermore, resistance and resistivity. So ito yung mga equation natin kanina. So due to our equation, we might think na in order for us to increase the resistance, ang kailangan lang natin gawin is increase the voltage. Kasi in this type of equation, you might um, reason out na proportion yung resistance and your volts are actually directly proportional. Pero because of the nature of the resistance and yung circuit, this is actually not the case. If we actually increase the voltage, ang nangyayari, tumataas din yung current. So as the voltage increases, mas mataas yung electric field or mas malakas yung electric field, mas mataas yung force na nagpo-pull sa ating mga electrons. Therefore, if we increase the voltage, our current also increases. So, ibig sabihin, nagiging constant yung ratio ng voltage at saka current. Therefore, yung resistance nagiging constant siya in this situation. So, from this what do you call this? From this discussion, then ang tanong is how could we increase the resistance? Kailangan, in order for us to answer this, we have to look at the factors that actually affect the resistance. And there are two factors that we have to look at. First is the dimensions of the resistor. And when we talk about dimensions, we usually talk about the length of the resistor and the cross-sectional area of our resistor. So kung gaano kahaba yung resistor natin, or sometimes a wire can be a resistor as well because it has a naturally built-in resistance depending on the material of the wire. So dimensions of the resistor or the wire, the length and the cross-sectional area. So kung gaano ka wide or kung gaano ka narrow yung area ng ating resistor or ng ating wire, it affects the resistance. Parang yung pinag-usapan natin noong una dito, kapag yung wire natin, let's think of this pipe as a wire. So mas kapag mas manipis siya or mas thin siya, mas maliit yung ating uh, or pag mas thin siya, na nag-change yung ating yung ating current. As you can see here, mas lumiliit yung ating So, depende kung gaano ka-narrow or gaano ka-wide yung wire natin, it affects the resistance. So, yun yung unang factor na nag-affect ng resistance natin. Yung pangalawang factor is kung ano yung material na makeup ng ating resistor. Is it aluminum? Is it copper? Is it gold? Is it silver? And depende sa material na gamit ninyo, nag-iiba yung tinatawag natin na resistivity. And we usually use the symbol rho to denote resistivity. So resistivity is the physical characteristics ng material that causes the resistance. Mamaya pag-usapan natin kung ano yung resistivity. So again, so ito yung mga factors na nag-affect ng ating resistance. One is the length. The longer the resistor, the higher the resistance. So kung mas mahaba yung wire or kung mas mahaba yung resistor, mas tumataas yung resistance kasi mas mahaba yung kailangan i-travel ng charge natin or yung electron. Since mas mahaba yung resistance, mas matagal siya ma-expose dun sa resistor, therefore mas mataas yung resistance. Pangalawa, cross-sectional area. The wider the area, the lower the resistance. Bakit kaya? Kasi kapag wide yung area, mas madaling makapasok o makapag-travel yung ating mga charge o yung ating electron. So if you narrow yung butas or yung road, let's think of it as a road. So kapag mas maliit, less yung width ng ating road, mas makitid siya, mas konting uh, mas mahirap pumasok yung mga sasakyan, di ba? So, in a charged particle, the wider the area, the lower the resistance. So, ibig sabihin, mas madaling makapasok yung ating mga charges. So, mas madali silang makatravel. So, the lesser the width of the area, or mas makitid siya, mas mahihirapan sila nakakapasok. Therefore, mas mataas yung ating resistance kapag makitid siya. Yung pangalawa, yung material makeup ng ating resistor. So yung resistivity is in some materials are naturally offer more resistance while others don't. The measure of resistivity rho, we usually use the equation rho is equals to the electric field multiplied by the current density. We talk about the current density, so lesson 13, which is basically the current per unit area, I over A. So that's how you solve for resistivity. So if you guys want to get reminded about current density, just look at lesson 13. So E is the magnitude of the electric field in the resistor and J is the current density from lesson 13. And we usually use the unit ohm meter or ohm times meter for our rho or for our resistivity. Again, so yung resistivity is basically a number that denotes yung natural characteristic ng isang material that causes the resistance. And dito meron kayong table of certain values of some of the materials that we use for as resistors. And we say at 20 degrees Celsius kasi mamaya pag-usapan natin how temperature also affects resistance and resistivity. So ito yung example ng mga material na ginagamit natin to talk about resistance and resistivity. So ang aluminum meron siyang resistivity na 2.75 times 10 raised to negative 8 ohm meter. And yun yung yun yung tatlong bagay that affects resistance. Yung length ng ating resistor, yung sectional area, cross-sectional area ng ating resistor, and lastly, yung resistivity rho ng ng material that makes up the wire or our resistor. Know that we know that the dimension and the area, the length and the area, and the material makeup of the resistor affects the resistance, then we can get a mathematical equation that we can use to compute for resistance. So to compute for resistance, we basically have to have the resistivity multiplied by the length of the resistor divided by A. So this is the second, or technically the fourth equation that I want you guys to remember. Resistivity is equals to rho multiplied by the length of the resistor divided by the area of the resistor. So when we talk about area, ito yung cross-sectional area. So kapag may cylinder ka, hatiin mo yung cylinder mo. So yung circle, when you look at the cylinder, yun yung cross-sectional area mo. So where rho is the resistivity of the material, which we use rho meter to denote as the unit to denote resistivity, length of the resistor in unit meters, and A is the cross-sectional area of the resistor in unit meter squared. Para mas madali ninyo ma-remember yung equation na to, you can think of it as the replay equation. So, ang R equals E PLA, replay equation, yun yung equation nyo to solve for resistance. So, now let's look individually dun sa mga factors that affect yung ating resistance, beginning with A, or the cross-sectional area. So the resistance R is inversely proportional to the cross-sectional area. We know that's inversely proportional because of this equation right here. So kapag mas mataas yung area ninyo, ibig sabihin mas wide siya, bumababa yung ating resistance. Kapag mas maliit yung area ninyo, ibig sabihin mas narrow siya, mas tumataas yung ating resistance. So they're inversely proportional. As the area increases, the resistance decreases, and vice versa. Thus, a thicker wire has less resistance than a thinner wire. And a mathematical rule, if two variables are inversely proportional to each other, then their product should be constant. So ito yung next equation that I want you guys to remember, the relationship between the resistance and the cross-sectional area on their own. As long as the other factors, meaning yung length and yung material na ginamit ninyo sa resistor are unchanged, you can use this equation to measure uh, the resistance or the area. Halimbawa, meron kayong isang resistor or isang wire and you want to see kung kapag linakihan nyo yung wire, kapag linakihan nyo yung area niya, paano magbabago yung resistance. So ganito yung relationship nila. So for example, the ratio of resistance of two wires made of the same material and having the same length is 1.4. Find the ratio of the area and the diameter. So yung given natin is yung ratio of resistance of two wires. So ibig sabihin may dalawa tayong wire. And yung ratio ng resistance nila is 1:4. So yung resistance ng first wire is 1 and yung resistance ng second wire is 4. And since the material and yung length ng dalawang wire is the same, so ang tinatanong niya, ano yung ratio ng area? To solve this, and ano yung diameter ng wire na ginamit. So ano yung difference between the diameter, the ratio between the diameter. So we can use this formula to solve for the ratio between the areas of the two wires and the diameters between the two wires. Solution. Use the formula to find the ratio of the area by arranging it. So we know this is the equation. We rearrange the equation by multiplying both sides by R2 and multiplying both sides by A1. So R1 over R2 is equals to A2 over A1. But we know that R1 and R2 is equals to 1 over 4 because that's the ratio. The ratio R1 is to R2 is equals to 1 is to 4. So R1 is 1, R2 is to 4. So A2 over A1 is equals to 4. Hence, yung ratio ng ating A1 is to A2 is basically 4 to 1. So A1 is 4, A2 is 1. So ito yung ratio ng ating area. So to solve for the diameter ng wire, we can substitute the equation for the area. So ang area ng isang wire or cross-sectional area ng isang wire is actually pi r squared. But since we're looking for diameter, we know that the r, to change it to diameter, we just have to, or r is basically diameter divided by 2. So d over 2 squared will give us d squared over 4 because d over 2 is radius. So pi r squared, to change it to diameter, is basically pi d squared over 4 because d over 2 is r, and d over 2 squared both numerator and denominator, you'll get d squared over 4. So we can substitute this to our A1 and A2, and we'll get that the ratio between the diameter between the first wire and the second wire is that your 2 is to 1. So, ganun natin makukuha yung ratio. So, how did we do that? So, A1, substitute A, D squared over 4. We denote this as the diameter of the first wire, and this is the diameter of the second wire. So, we can cancel the pi, we can cancel the denominator 4, which will give us basically uh, d1 squared over d2 squared is equals to 4 over 1 because a1 over a2 is 1 over yeah, a1 over a2 is 4 over 1. This is a2 a1. Square both sides, you'll get the d1 over d2 is equals to 2 over 1. We square both sides because this is square. The numerator and the denominator are both square. Just square both sides and you'll get that d1 over d2 is equals to 2 over 1. So this is the ratio of the diameter of the two wires. Second is yung length. How does the length affect the resistance? So we know that the resistance R is actually directly proportional to the length of the resistor or the wire. As the resistor's length increases, the resistance also increases. That's what directly proportional mean. Ha? Pag tumaas yung isa, tataas din yung isa. And mathematical rule, if two variables are directly proportional, their ratio should be constant. So meaning, yung ratio between the resistance and the length of a wire should be proportional to the ratio over length of another wire, provided that the wire or the resistor's material and area are unchanged. So I want you guys to remember this. As long as the other factors, meaning yung material and yung area, is the same, pareho ng material, pareho ng area, then we can use this relationship to solve for resistance and the length of a resistor or a wire. Sample problem 14.3. A wire is 100 centimeter long and has a resistance of 25 ohms. The wire is cut into 5 equal parts. A. What is the resistance of each piece of wire? B. If the 5 parts were bundled together, what is the resistance of the resulting wire? So ngayon, meron kang sinabi niya na meron kang isang wire and yung haba ng wire mo is 100 centimeter. That's our first given. Ang pangalawa, yung resistance ng wire na yon is 25 ohms. Ang tanong niya ngayon, ano yung resistance ng each piece of wire after mong hatiin yung 100 centimeter into 5 equal parts. So, ibig sabihin yung length mo, lumiit siya. So, ngayon, ano kaya yung resistance nung wire na yon, nung mas maliit na wire? And pangalawang tinatanong niya, kapag pinagsama-sama mo yung 5 wire, so yung R bundle, so yung 5 wire na yun, yung 5 equal parts of wire, you added them all together, you twisted it into one wire, ibig sabihin yung area lumaki, tama? So R bundle, ano kaya yung resistance after mong palakihin yung wire? So yung formula to use is this one. So R1 over L2 is equals to R2 over L2. Solution, since our wire is divided into 5 equal parts, hence each shorter wire is actually 20 centimeter now, because 100 centimeter divided by 5 is 20 centimeter. And we're going to use this 20 centimeter as our new length. So we can use this equation to solve for the new resistance. So rearranging the equation or plugging in the numbers, R1 is 25 ohms. The length of our original wire is 100 centimeter. Ang hinahanap natin is R2. And the length of our new wire, yung 5 wire, is 20 centimeter each. So ibig sabihin, simple algebraic solution, yung resistance ng isang 20 centimeter wire is actually 5 ohms. The shorter wires were bundled together, so it means the area increases 5 times the area of the shorter wire. So originally, meron kang isang wire na 20 centimeter long. That tama? And yung 20 centimeter long wire na to, meron siyang area. So kapag yung limang 20 centimeter na yon pinagsama-sama mo, ibig sabihin yung total area ng wire na yon is 5 times dun sa area ng 20 centimeter. Tama? So, papaano natin kaya solve kung ano yung bagong resistance kapag pinagsama-sama mo yung limang shorter wire na yon. So, we can use yung previous equation na ginamit natin kanina. So, ito yung A2 is yung area ng R2 nung 20 centimeter wire mo and yung resistance niya which is 5 ohms. And yung A3 is yung area ng limang wire na pinagsama-sama mo. And we know that A3 is equals to 5 times the area of the shorter wire. So, ibig sabihin, A3 is equals to 5 A2. And ang tinahanap natin ngayon is ano yung resistance ng bundled wire. So, to solve for this, we basically have to divide both sides to 5A2. So, yung resistance ng bundled wire is 1 ohms. And we know that this is correct because ano yung sinabi natin kanina, kapag mas mataas yung area, kapag mas wide yung area, ibig sabihin mas mababa yung resistance. So, dito, meron tayong isang 20 centimeter na wire, yung resistance niya is 5 ohms. And dito, meron tayo ngayon na limang 20 centimeter wires na pinagsama-sama natin into bundle. So, ibig sabihin yung area niya mas malaki or mas malawak. So, ibig sabihin yung resistance dapat bumaba siya. And we got it right. Yung alam natin yung resistance bumaba because our answer is 1 ohm. Next, yung material of the wire or yung resistivity. So, the effects of the kind of material on the resistance is determined by its resistivity rho. Sample problem 14.1. An insulated extension cord is made of 1.5-meter long copper rod with diameter of 2.3 millimeters. So ito yung ating resistor. Isang copper rod na may diameter na 2.3 millimeter. Ang tanong, what is the resistance of the extension cord? Pangalawa, if an aluminum wire of the same length will be used instead of copper, what should be the diameter of the aluminum wire to have the same resistance? So, ang pangalawang tanong niya is kapag pinalitan natin yung copper into aluminum, same length, but we want to solve for same resistance, gaano dapat kalaki or kaliit yung diameter ng aluminum? So, let's write our given first. So, ang binigay sa atin is yung length ng ating copper wire or copper rod is equals to 1.5 meters. And yung diameter ng ating copper is 2.3 times 10 raised to negative 3 meters. So, I converted 2.3 millimeters to 2.3 times 10 raised to negative 3 meters. So, yung raw copper is equals to 1.72 times 10 raised to negative 8 ohm meter. And yung raw aluminum is equals to 2.75 times 10 raised to negative 8 ohm meter. So, saan natin to nakuha? We got this from the table that I showed you earlier. So, yung table, dun yung makukuha yung resistivity ng aluminum and copper. So in our test, if you have a question similarly like this, I will provide the table for you guys to look at kung ano yung row, or sometimes ibibigay naman siya dun sa ating problem. So if it is given to you on the problem, you don't have to look at the table. But in this kind of situation where they didn't give it to you, then you have to look at the table to identify kung ano yung resistivity ng material na ginamit. So, ang tinatanong niya is, ano yung resistance ng copper rod? And pangalawa, what is the resistance of the extension cord? And pangalawa, ano yung diameter dapat ng aluminum if we change the copper into aluminum? And gaano dapat kalaki or kakapal or kanipis yung aluminum para magkaroon tayo ng same resistance. And the formula that we have to use is our replay formula. Resistance is equals to rho times the length divided by the area. So we know that this should be our equation kasi ngayon ang pinalitan natin is yung material makeup. So maapektuhan yung ating rho. So ibig sabihin, we have to use this equation to solve for the resistance and for the diameter ng new material natin. Solution. To get the resistance ng copper rod, we have to use this equation then to get the resistance of our copper rod. Um, in order for us to do that, ang kailangan muna natin i-solve is yung area. Kasi binigay sa atin yung length ng ating copper and alam natin yung row ng ating copper. Ang hindi natin alam is yung area ng ating copper rod. So, let's solve first the cross-sectional area of our copper. So again, yung area ng isang rod, ng isang cylinder, yung cross-sectional area ng isang cylinder, ng isang wire, or ng isang rod is pi r squared. Pinag-usapan natin yan kanina. Again, r is basically d over 2. Since ang binigay sa atin is diameter ng ating material, we can use d squared over 4 to solve for the area. Substitute the number 2.3 times 10 raised to negative 3 meters to squared over 4, and then the measurement ng area ng ating copper is 4.15 times 10 raised to negative 6 meter squared. Now we can use the area and substitute it dun sa formula natin to solve for the resistance of the copper rod. So the resistance of the copper rod is equals to the resistivity of copper multiplied by the length of the copper rod divided by the cross-sectional area of the copper rod. Ang sagot natin is yung resistance ng copper rod is 6.217 times 10 raised to negative 3 ohms. So yun yung letter A natin. Letter B. Ang tinatanong sa letter B is ano yung diameter dapat ng aluminum. So if we have an aluminum instead of a copper rod and we have the same length and we want to get the same resistance, ano kailangan yung diameter ng ating aluminum para makuha natin yung same resistance. So we know na yung length natin ng ating aluminum is the same ng length ng ating copper, which is 1.5 meters. And alam natin na yung gusto natin makuha is the same resistance for our aluminum and our copper, which is 6.217 times 10 raised to negative 3 ohms. Ito yung sinulog natin sa letter A. And we know that the relationship between the resistance and the length is that our aluminum is equals to length aluminum should be equal to the resistance of the copper divided by the length of the copper. We know this because if the resistance and the length are directly proportional, and when two things are directly proportional, then the ratio should be constant or should be equal. Pinag-usapan natin yan kanina. So from this equation that the resistance is equals to rho times the length divided by the area, if we multiply both sides by the area, we'll get this equation right here. So times A, we'll get this. And kung mapapansin ninyo na yung resistivity ninyo and yung and area are directly proportional. So yung resistivity ninyo, yung rho, not resistance, this is the resistance, this is the resistivity. And yung area is actually directly proportional. And similarly, if two things or two variables are directly proportional, meaning their ratio should be constant. So parang ito lang. So we know that R and L are directly proportional. So R over L is equals to R over L. Here, same, the area and the resistivity or rho are also directly proportional. So the resistivity of aluminum divided by its area should be equal to the rho or resistivity of the copper divided by the area of the copper. And this is true provided that all other aspects remain constant. And we know that the length and the resistance are constant, they are unchanged, so we can use this. So multiply both sides by the area of the aluminum, then divide both sides by uh, oh, basically cross multiplication, and then divide both sides by the resistivity of the copper, and simple algebra rearrangement, we know that the area of the aluminum is equals to the resistivity of the aluminum multiplied by the area of the copper divided by the resistivity of the copper. And substitute the number. So the resistivity of the aluminum, we get this from the table. And the area of the copper is, we solve this area of the copper in A. And then the resistivity of the copper, again, we can get this from a table. Then we know that the area of the aluminum is 6.635 times 10 raised to negative 6 meters squared. So now we can use this aluminum to solve for the diameter of our aluminum. So solve for the diameter of the aluminum. So again, the area is equals to pi d squared over 4. So to get the diameter, rearrange the equation, multiply both sides by 4 and divide both sides by pi. And then squared both sides because this is squared. So to remove the squared, so we know that the diameter of the aluminum is basically is equals to 2 the square root of the area of the aluminum divided by pi. Substitute plugging in the numbers and you'll get that the diameter of the aluminum should be 2.907 times 10 raised to negative 3. If this is the diameter of the aluminum, then we'll be able to get the same resistance as the resistance of the copper. So that's how we solve equation like this. So temperature. So another factor that affects resistance that is not a physical characteristics of a resistor, so meaning hindi siya dimension, meaning hindi siya length and area, and hindi siya material ng resistor is yung temperature. Resistance and resistivity varies with temperature. As temperature increases, resistance and resistivity increases for conductors and decreases for insulators and semiconductors. This is a very general term. Sometimes may mga situation that this does not apply. But for all the purposes of this lesson, let's think of this as always through para hindi tayo mahirapan because medyo complicated if we do not assume this right here. Again, as temperature increases, tumataas yung resistance and yung resistivity ng conductors. And bumababa naman yung resistance and resistivity ng insulator and semiconductor. The temperature dependence of resistance and resistivity is nearly linear. So we can solve for resistance and resistivity using temperature using this equation right here. So this is the linear uh, temp temperature equation that we can use to solve for rho at a certain temperature or resistance at a certain temperature, where rho sub t is the resistivity at temperature T, and rho sub O is the resistivity at a reference temperature T0. So when we use rho sub 0 or T sub 0, usually ito yung reference temperature ninyo. It's usually either 0 degrees Celsius or 20 degrees Celsius. And yung T is the new temperature that you are looking for. Same thing for RT is the resistance at temperature T. And R sub O is the resistance at T0, which is a reference temperature. Yung alpha is the temperature coefficient of the resistance. The unit alpha is a reciprocal to the temperature, usually 1 over C degrees, over Celsius degrees. So Yung alpha, you have a table to look at the alpha or yung coefficient of resistance. And it's usually a number over Celsius degrees. So ito yung conductors and semiconductors. So these are some example of the materials at 20 degrees Celsius. So make sure, so guys remember this is at 20 degrees Celsius. This is usually your reference temperature or T0. So when you need to look for your alpha in your previous equation for this, then just use this table right here. Sample problem 14.5. The resistance of a platinum wire at 30 degrees Celsius is 15 ohms. Find its resistance at 45 degrees. Note that the coefficient of resistance of a platinum wire is 0.0039 over Celsius degrees at 20 degrees Celsius. So how are we going to solve this? So first, let's write our given. So yung temperature natin is at 30 degrees Celsius. And yung resistance ng platinum wire at 30 degrees Celsius is 15 ohms. And yung coefficient of resistance niya is 0.0039 degree per Celsius degrees. Pero this time, this is at 20 degrees Celsius. So this is important to remember. This is a 20 degree Celsius. Ang tinatanong niya ngayon is, ano yung resistance at 45 degrees Celsius? So, tinaas natin yung temperature niya, ano yung bagong resistance ng ating platinum wire? So, yung formula, we're gonna use this equation right here. So, isa sa mga equation na pinakita ko kanina. Solution, yung coefficient of resistance natin is given at 20 degrees Celsius. So therefore, we have to use this first as our reference temperature, T sub 0, and then first solve for R20. So bago natin makuha yung R at 45, resistance at 45 degrees Celsius, we have to get the resistance at 20 degrees Celsius kasi binigay na A sa atin. To solve for this, we have just to substitute. We have the resistance at 30 degrees Celsius is equals to resistance at R20 plus the resistance at 20 degrees Celsius times the alpha times T minus T sub 0. So 30 degree minus 20 degrees Celsius. So we're solving for R20, so it means we have to pull this R20 out, substitute, and then substitute the numbers. So we know that our resistance at 30 degrees is 15 ohms. Pull out the same variable, which is R20. So this makes that 1 plus, this is our A, and this is 30 minus 20 degrees Celsius, which is 10 degrees Celsius. So if we substitute back R20, we'll get the top one. So we just have to pull out R20. So basic algebra. And then what we have to do is divide both sides to 1 plus 0.0039 per Celsius degrees times 10 degrees Celsius. So we get that the resistance at 20 degrees Celsius is 14.437 ohms. Now we can use R20 to solve for R45 using again R20 as our T sub 0, our reference temperature. So the resistance at 45 degrees Celsius equals to R20 times the resistance at 20 degrees Celsius times A. We use the same A because we're using the same reference temperature at A. And then 45 minus 20 degrees Celsius. Plugging in the numbers, we'll get that the resistance at 45 degrees Celsius of a platinum wire is 15.8 ohms. And so that's what temperature is about. And lastly, yung topic for this one is the electrical conductivity. If electrical resistivity rho is the physical property of the material to resist current, electrical conductivity sigma, we use the symbol sigma, is the physical property of the material that determines the ease at which current flows through the material when it's subjected to an electrical field. So Kumbaga, their opposite. Electrical resistivity impedes or prevents the current to travel smoothly. Electrical conductivity helps the current to travel smoothly. Resistivity is inversely proportional to conductivity and vice versa. So resistivity is equals to 1 over conductivity, or conductivity is equals to 1 over resistivity. And this is true because the lower our conductivity, the higher the resistance. And the lower our resistance, the higher our conductivity. Moreover, in some materials, current density is proportional to the electrical field and the proportionality constant equal to the conductivity. So, current density, we've discussed about current density. We can also use this equation, which is electrical conductivity times electrical field is equals to current density. So rearranging this equation, we can use this equation right here to measure conductivity. So electrical conductivity is basically equals to the current density divided by electrical field. And if you guys go back to resistivity, uh, E is E over J is rho. E, pag pinagpalit nyo to, E instead of J over E, ginawa siyang E over J, is actually equal to resistivity. So if you guys go back, you can actually see that. And from lesson 13, we know that the current density is equals to numbers per meter cube times the charge of the electron times the electron mobility times the electrical field. Just substitute the value of J in this equation. We can also use this equation now to solve for conductivity, which is equals to sigma is equals to number of free electrons multiplied by the charge of electron, which is negative 1.602 times 10 raised to negative 19 coulombs, and micro is sabi ko kanina, this is the electron mobility, and usually it is given in the problem. So we're not gonna totally focus on electrical conductivity. It's just something that I want you guys to know yet, because we're going to discuss this at lesson 15. So that's all our topic for today. It's quite long and there's so many equation that I want you guys to remember, but I hope you guys understand it. Again, this talks about electrical resistance. So, things na nagpapabagal dun sa pagdaloy ng electrical current sa ating resistor or sa ating wire. Okay? And yung dimension ng ating resistor or wire, yung area and yung length niya, and yung material ng ating resistor or wire affects resistance. And I've given you all the equation that I need you guys to remember in order to solve for resistance. And we'll also discuss four things that affect this resistance individually, and some equations that we can use to solve for either the dimension, for the area, the length, temperature, and the material of our resistor. So if you guys have any questions, I know this is quite a lot to remember, but I hope you guys understand this. If you guys have any question, just shoot me a message and I'll help you guys anytime. My messenger is always open, and I hope you guys have a good day, and thank you very much.